Now this is exercise 11.4, question 11, and it's a similarity proof. Now in this question we are told that A and B are the midpoints of PQ and PR respectively. So we can see that there because PA equals AQ, A is therefore the midpoint. We can see those equal markings, and we can see that PB equals BR, therefore B must be the midpoint of PR. And we can see equal markings there, but notice that they're different. They've got double dashes here, whereas they've got single dashes over there, meaning that PQ does not equal the length PR. However, A and B are still midpoints of those sides respectively. In this question, we have to prove that triangle APB is similar to triangle QPR. And if you look at the question, the only thing that we can really see is that angle P is common to that small triangle and the large triangle. And we know information about the sides PA and PQ, and we have information about the sides PB and PR. Now, because we know that A is the midpoint, we can say that really that PQ is double the length of PA, or that PA is half the length of PQ. So we can start with ratios of sides. So we can say PA over PQ equals 1 over 2. In other words, it equals a half. Reason being is that A is the midpoint of PQ. And similarly, we can say that the ratio of PB over PR is a half as well, because B is the midpoint of PR. Now, the other thing that we know is that we have this angle P here. It's a common angle. So we can say that angle APB is equal to angle QPR, reason being that angle P is common. Now, we really have to know here that we do have two triangles. We've got triangle APB and we've got triangle QPR. So we've just proven that the ratio of PA over PQ equals a half, and that the ratio of PB over PR is also a half. So these two ratios are equal, and we can see that the angle in between them, angle P, is common. So therefore we have enough to prove that the two triangles are similar. So we can say, therefore, triangle APB is similar to triangle QPR. Reason, we could say sides about equal angles are in proportion. Or we could say two angles are in proportion and the included sides are and the included angles, are equal. So I might just actually write that in. I'll just write two sides in proportion and included angles are equal. But either reason is fine. Now in part B, we have to hence prove that QR is parallel to PB, and we have to prove that QR is twice the length of AB. Now, when we look at lengths of sides, we need to compare them with the lengths of the other sides in the triangles that we know, because whenever we've tried to find out lengths of sides in similar triangles, we always do ratios of corresponding sides. So what we do know so far is that PA over, I was saying PA, ratio of PA over PQ, we know equals the ratio of PB over PR, but that also equals the ratio of AB over QR, because we're doing the small triangle over the big triangle. So PA over PQ is equal to PB over PR, which equals AB over QR. Now you don't need to do the whole three sides. You only need to do two sides at a time. So here we're saying that AB over QR equals, I'm going to choose this side, PA over PQ. Now, to give a value to AB and QR, you need to bring in some of these values that we used here in part A. Now, we said AB over QR equals PA over PQ, but we can also say, well, we know that the ratio of PA over PQ is also a half. Now, because we've got PA over PQ twice here, we can now therefore say, well, AB over QR therefore is equal to a half as well. You know, that's because both those ratios here are equal to PA over PQ. Now, because again, we know that the ratio of AB over QR is a half, we know that therefore that QR is double the length of AB. So we can write that down there. So therefore QR equals 2 times AB. So we've therefore proven that QR, is twice the length of AB. We now need to prove that QR is parallel to AB. And of course, to prove parallel lines, we either have to use corresponding angles, show that they're equal, or alternate angles, or co-interior angles, show that they're supplementary. Now, because we've got two similar triangles, we can actually mark in the corresponding angles. So I'm just going to do that now. So because we know that these triangles are similar, we can say, well, angle PAB is equal to angle PQR because they are matching angles of similar triangles. So we've just got that there. So angle PAB is equal to angle PQR, reason being that they are matching angles in similar triangles. We also, if we look at the positions of those dots there, we can see that they are in corresponding positions. So we can say, well, and angle PAB and angle PQR are corresponding angles as well. But we also know that they're equal. So we can now say, well, therefore, AB must be parallel to QR because these two corresponding angles that we're talking about, angle PAB and angle PQR, well, they're corresponding, but they're also equal. So we can say that we've got corresponding angles that are equal. So therefore, because corresponding angles are equal, we can say that QR is parallel to, that AB is parallel to QR because the corresponding angles are equal. And hence we've proven what we set out to prove in part B, that we've proven that QR is parallel to AB, and we've also proven that it's also twice its length. And that's the end of question 11. Just also, you could draw triangle PAB and triangle PQR separately as you do this question.